Hi, when we were doing the part 16 video, I sought out to fix a bug that was pointed out by one of our forum members. So he very kindly took a screenshot of the issue, and this perfectly captures the issues that we have with our current pickup system. Which is that if you go too close to a object and then you walk at a certain angle that is very sharp to where it's supposed to move towards you from, the pickup is just gonna miss you, straight up miss you, because the pickup doesn't home in on you, just tries to move to where you were initially at when you try to pick it up. And notice also that even though the pickup is missed, you see the player still gains experience. So basically this pickup is going to give experience to the player and then fly to the edge of the map forever, lost in space. Okay, so this is something that we don't want, right? Because if you have an object that's just flying forever towards a certain direction, it's memory. They're just there, but they don't really do anything, right? So in this part of the series, this is what we're gonna fix. So for me to run through with you how the current pickup collection works, the whole thing actually starts with the player collector script. So let's go through what the player collector script does. Before we talk about the optimizations, let's talk about the main problem with the player collector script. Okay, so firstly, it has a on trigger enter 2D, and this is what powers the entire script essentially. So the player collector is attached to the player character himself, and what's happening here is that there is circle collider paired together with the player collector script. So notice that the player has two colliders. Okay, one which is the actual player's collider, and the other one is the collector radius. And the collector radius changes size when the game starts. So if I were to run this game, and if we were to check out the collector, you will see the collector's radius is larger now. And this is because the collector's radius is drawn from the player stats, which is right here. So this player has a magnet stat of 1.8, and this is why the radius is so large. It's going to be updated every frame by the player collector. So what this circle collider does is it checks whether the object is a collectible, and if it is a collectible, what it does is that it calculates the direction in which it's supposed to move. So it basically gets you a vector that points to the player, and then it applies that vector as a force. So the object essentially flies towards the player. Nothing wrong with the math over here, it's perfectly good vector math. It's just that it only works for one frame, and therein lies the problem, because in the first frame that the circle collider touches the gem, if it moves towards where the player is and the player is moving, when it reaches where the player should be, the player might have moved somewhere else, and this is why we get problems like this. So to fix this, what we have to do is we have to get the gem to follow the player, so it has to home in on the player, which means that we have to be updating where the gem is traveling towards at every frame. So this presents a couple of problems. So if you have multiple gems that you are supposed to pull towards yourself, you will have to keep track of all the gems that you have collected but have not reached you. It's gonna be a lot of work on the player collector, and it's gonna make everything really complex. So when I set out to implement this, what I wanted to do was to let every pickup handle its own homing. So when the player collector touches the pickup is gonna just figure for itself, how am I gonna get to the player collector? So the logic for applying the forces and everything, we're just gonna move all of this stuff over to the pickup class. Okay, so this pickup class, right? It serves as a parent class, and it has a collect function that basically, when you collect the pickup, it will mark the pickup as having been collected. This is so that you cannot pick up a pickup multiple times, otherwise the effects can potentially be applied multiple times for one single experience gem or for one single health potion. So the other thing that the pickup script does is that when it touches the player, it will just destroy itself. The pickup script is very bare, and it really doesn't warrant having a class all to itself, alright? Just because there isn't a lot of code. I just like to make sure that my classes serve more of a purpose. What I'm gonna do over here is I'm just gonna move the behavior on the player collector over to the pickup script. Let me just go through the code from the post. Okay, so what's happening here is that the main thing that's happening here is basically that I've added an update function onto the pickup class, and in the pickup class there is code that pushes the gem or whatever the pickup is towards the player character. So before we get to the update function, let's talk about the collect function over here first. Okay, so the collect function is gonna function the same as in the previous pickup class. When the collector's radius touches anything that is a pickup, the collect function is going to be called. But this time the collect function is not just going to flip a boolean. It's going to populate a couple of variables. Essentially, it's still flipping the boolean. But right now, we don't use a boolean anymore. So what we have here is the most important variable here is the target. So when you call collect, whatever target you pass on to collect is going to be stored inside the class. So if you see in the class, there are 3 variables here. Target and speed are private. And target is basically the player that you are flying towards. This makes it so that it's possible to accommodate multiple players in the game. So in the future, if we want to implement multiplayer features, it's going to be easier. Okay, so we assign a target to the class. We also assign a speed. Again, speed is protected. So when you call collect, you're telling this pickup who to fly towards, how fast to fly towards. And then finally, you have lifespan. Even though we have a homing code and I think it works perfectly fine, it is possible for the pickup to not be fast enough to reach you, and then you can outrun the pickup forever. So I'm doing here is I'm specifying a default lifespan of 0.5 to all our pickups, and you can override this if you want to inside the function itself. So what's going to be happening in collect is when we specify that there is a target and a speed so that the pickup knows to move towards the target and what speed, we also specify a lifespan. So if the item or the pickup, if it chases the player for a certain amount of time and it fails to reach the player, it's just gonna destroy itself and then apply its effects to the player. This is just a failsafe to avoid any extreme cases. So finally, we have this destroy function here, which destroys the pickup, and this basically just applies the lifespan. Second argument in destroy is always going to apply a timer. So for example, if I put here destroy game object 0.5, then this is going to take 0.5 seconds and it's going to destroy the game object after 0.5. So what is this mathf max over here? What this is this picks the larger of the 2 numbers. So if the lifespan is a value that is below 0, what's going to happen here is it's just going to pick 0.01. What this ensures for us is that minimally the pickup after being collected, it will exist for at least 1 frame. So what collect does essentially is that it populates the target variable inside the class, and if you look at the update function, if there is a target, we will move the pickup towards the player. Okay, so I'm just gonna pull up Play and just do some drawings and show you how all this stuff works. So we have an article about vector mathematics in our blog, and the reason I wrote that was so that, well, in our tutorials there's a lot of vector math involved, and I don't want to keep repeating the same points over and over again, even though I'm doing it now. So we have, let's say, the player, and say its player is here. And then we have the pickup. So the pickup, let's call it X. What we want is for a vector that points from the pickup to the player like this. Alright, so this is the vector that we want. To get this vector, we will have to grab position of the player minus the position of the pickup. So that will be P minus X. Whatever that is in front will always be where the vector is pointing towards. Alright, so because we want it to point towards the player has to be the first thing, and then we have to minus this away from the position of the pickup. So this will give you a vector that points from X to P. It's just the way vector math works, right? 2 things we can do with this vector. We can convert it to a unit vector, and then we can use it to push the object towards the player, because the vector is an arrow, right? So if you add it to the position of the object, then essentially you're moving the gem towards the player. Second thing we can do with this is we can measure the distance of this particular vector as well. 2D vectors, they actually form a right angled triangle, so you can apply all kinds of trigonometry to them. If you remember Pythagoras theorem, if you have the x and you have the y, you can calculate the length of the vector. So the length of the vector will be equivalent to the distance between the 2 objects. So over here, what I'm doing in the code here is I'm grabbing this, which is a vector that points from the object to the player, and then I'm also using this vector as a way to measure the distance between the 2 objects, essentially killing 2 birds with 1 stone. And you will see there's something weird here, and the something weird is that I'm using the square magnitude of the vector and comparing it to speed times speed instead of using magnitude, which is the actual length of the vector. So square magnitude is used because square magnitude is cheaper to compute. So every vector has a length, right? The length is calculated essentially from x square plus y square, and then you square root. So this gives you the distance or the magnitude of the vector, right? Because square roots are expensive, instead of using the magnitude, what I'm gonna use is I'm gonna use the magnitude square. And when I use the magnitude square, what's gonna happen is that I can just grab x square plus y square. So this is just a small optimization that I'm doing when we are looking for the distance between the gem. So it's easier to multiply 2 numbers together than it is to square root a number, which is why I use square magnitude. And why time at a time is necessary? Why don't we just take speed times speed. It's because time of data time will account for when there is lag. When there is lag, time of data time will increase, and this will cause the measurements and everything to change as well. So time of data time is a very important part of our formula here. So essentially what we are doing is we're checking if the distance between the gem and the player is greater than the amount of distance that the gem will be traveling for this frame. If it is greater than that, that means that the gem has not reached the player, and then we will push the gem towards the player. Now we are using the distance vector, but for a different purpose. We are normalizing it. Normalizing a vector, essentially, let's say this, we want, say this vector we have, right? When we normalize a vector, what we are doing is we are getting the vector but with a length of 1. So the benefit of having a vector with a length of 1 is that it becomes something called a unit vector. And a unit vector is basically, because it has a length of 1, if you multiply by any number, it's gonna become whatever the length you want it to be. So for example, if I want a vector that points in a certain direction with a length of 5, I will just grab the unit vector, multiply by 5, and I'll get the same vector pointing in the same direction but with a length of 5. Right, so this is an easy way. When we normalize the vector, it's an easy way for us to control how long the vector is, and by extension control the speed. We normalize the vector, then we can multiply by speed and time of data time, okay, which gives us the amount of distance and the direction, of course, of that the gem should travel for this particular frame. And because this distance vector is calculated every frame, the direction that the gem travels every frame is going to update itself, which essentially makes the gem home in on the player. If the distance between the gem and the player is less than the amount of distance that you will travel for this frame, that means that you effectively have reached the player, and then you just destroy the game object when the pickup reaches the player. So the pickup script has two changes. One is collect. Main thing it does is populates the target variable, and when it's populated, it will cause update to push the item towards the player. So the next thing we are doing here is we're just removing the onTrigger enter 2D function. We are removing this because we are already handling the removal of the gem when the gem reaches the player. So notice one thing that we are doing with this pickup script also is that we are removing the reliance of the pickups on Unity's physics system, because now we are doing the calculations ourselves, and so this makes the entire thing run faster as well, which is always a good thing. Okay, we remove has been collected because its duty is now performed by target. So the other thing that we are doing here also is we are removing this iCollectible interface. And I guess your first question will be, what are interfaces? Okay, let's look at what the iCollectible script does first. It's an interface that has a void collect, and what this does is that anything that implements this interface will have to have a collect function, okay, which pickup has, so it's fulfilling the interface requirement. Interfaces are meant for us to use as a bridge whenever we have multiple hierarchies of different classes. One example I can give for you is that, so in the projectile script, you will see inside onTrigger enter 2D, when the projectile hits something, right, it's gonna check whether the other thing that it's hitting is either an enemy, has an enemy stats component, or whether it has a breakable props component. And if it's an enemy, we will damage it in a specific way, and if it's a prop, we will damage it but in a different way. Even though both have a take damage function, you cannot just check for both things at once. We have to check for them separately. That's because the enemy stats object and the breakable props, the classes, they both belong to different hierarchies. This will look something like this, alright? So we have enemy stats, and this enemy stats, because it represents enemies, in the future we may have different kinds of subclasses. Okay, so maybe we will have just some random examples. There may be more subclasses depending on how many kinds of enemies you want to have. Okay, so we also have another hierarchy of objects, right? So over here we have the breakable props. And again, breakable props in the future, depending on what kind of features we want to have, we may have different subclasses for these props as well, right? So they belong to different hierarchies, but sometimes because they both take damage, right? So we want to be able to manage both of these as the same kind of objects. Interfaces are one way that you can do that, and we can create an interface and we can call this interface, let's say iDamageable. And then what this iDamageable interface is gonna have is it's gonna have a definition for a function called take damage, which will specify that anything that implements this interface has to implement the take damage function, for example. So if we were to have an interface like that that unifies both the enemy stats and the breakable props hierarchies, in our code we can handle both of these as a single unit. We can use like iDamageable same D, okay, and then we can just do other get component iDamageable. So what iDamageable will do is that if there is an enemy stats, it will find the enemy stats. If there is a breakable prop, it will find the breakable prop, because it treats both of them as the same kind of object. Alright, so essentially interfaces are there because you want to unify the hierarchies of two different classes of objects. So the iCollectible in our code is only implemented by the pickup script, okay, which means it doesn't do anything. It doesn't serve a purpose. Maybe in the future it will serve a purpose and we'll bring it back, but for now, because it doesn't serve a purpose, I'm gonna remove. Okay, and of course a bunch of other changes, so I'm just gonna copy this whole thing and just drop it into my code base. Once you make the changes to your pickup script, there'll be errors that appear and you will have to start cleaning up all these errors. That's what the rest of this part is meant to address. Okay, so let me delete the interface as well. Okay, we don't need the interface here for now. So once you make the changes to the pickup script, the most immediate thing that we have to update is the PlayerCollector script. So what's happening with the PlayerCollector script, right, is that, okay, the collectible is gone. So over here, instead of collectible, we can just use pickup, alright? The main thing that we have to address is that the collect function now takes 3 arguments. So that means that we will have to specify who the pickup is flying towards, how fast it's flying towards. Finally, it's the lifespan, okay? So the lifespan is optional. So if you leave it at 0, it's just going to take the lifespan that is set in the default value over here, right? Which is totally fine. So what we want to do here is under the collect function, we have to give the player and as well as the pool speed. Okay, this will fix the issue in the player collector. And also because the movement has been moved to pickup, we can remove code right here. Okay, the other change that I want to do, there are 2 more changes. First one is find object of type over here. Okay, this can be used when you have one single player. So we are just gonna lay a bit of groundwork and then let's just change this to get component in parent. Because when you find object of type, what it's gonna do is it's always gonna find the same player stat. So let's say if you have multiple players and every player has a collector, it's always gonna find the player stats object of the first player. So if you have multiple player stats, you're not gonna be able to find all of them. We want every collector to point to the correct player. So we cannot use find object of type. Instead, what we want to do is we want to just find the component in the parent object so that it's multiplayer compatible in the future. Second change I want to make is to rename the player collector circle collider. And what's happening here is that I'm just going to change this to detector. And one thing that you want to do whenever you try and rename a variable, very useful feature, is you can just right click and rename. And over here I'm just going to name it detector. It's just the smoothest sounding name. Okay, you can keep it as the original name if you want to. I just like my names to be shorter and more descriptive. One inefficiency that I find here is that the detector's radius is updated every frame. In the player stats, there is a stat called magnet, and then every frame it just retrieves the magnet and then it updates the radius. This is not efficient because the collider is linked to the physics system. So whenever you change the size of the collider, the physics system has to do some work to update the collisions and whatnot. So what I like to do instead is let's remove the update function and replace it with a function called set radius. And what set radius does, it takes a float r and it sets a detector radius be equals to simple as that. I'm also not gonna retrieve the detector's component in start. Instead, I'm gonna move this over here. If there is no detector, then for the first time we will assign detector as the circle collider in this particular game object. Actually, whenever there's a change in the player stats, we will want to just update the radius because the magnet stat could have changed. This set radius function is gonna be called inside the player stats script later on. So whenever we try and change the stats of the player, we will call set radius. Why is it that I moved the get component from start over to set radius? Because if the detector is populated only in start, we will not be able to call set radius whenever you have a wake function, and I want to be able to call set radius when there is a wake. So to do that, if I put this in start and then I call the set radius function and awake in a different script, the detector will not be present and then this will cause a null reference exception. So to prevent that, I populate the detector the first time this function runs so that it's always accessible, always available. It only fails if you don't have a circle collider, okay, which we're going to remedy also by adding a required component here. This is a directive, and what this directive does is that it ensures that whenever you have a player collector, it always comes with a circle collider. Okay, so the set radius, because now we have to specify when the radius is updated, which means that we have to head into player stats, and then we have to find all the parts in our player stats code where the radius is updated, and then we have to call set radius. Okay, simple, right? So because the player stats currently doesn't have a reference to the player collector, we have to add a player collector variable here. Let's call this collector. And then under awake, we will find both the inventory and the collector. And what we want the player collector to do is whenever the stats are updated, we also want to update the collector radius. Which means over here, after the stats are updated, I'll do a collector set radius. And then the radius that is set will be actual stats dot. This will be applied also to recalculate stats. So over here, same thing, actual stats, and then So we have to find wherever stats are updated and just call collector set radius, and then this will do the job for us. So both our health potion and experience gem are subclasses of pickup, which means that if you recall, I was explaining just now, the health potion extends pickup, and basically it just expands the collect function and it adds a functionality over here to restore the player's health. So whenever it's picked up, it will restore the player's health, and for the experience gem, whenever it's picked up, it will grant experience to the player. Okay, it's all fine and dandy, except that again, the classes here are pretty empty. So whenever I find something that doesn't have a lot of code, I like to delete these. Okay, so we are gonna merge the functionality of both the experience gem and the health potion into the pickup class. So I'll delete health potion here, I'll delete experience gem here. And in the pickup class, I'm gonna add the bonuses here. And over here, this will be experience and health. We want it to be possible for our pickups to grant either experience or health, or both. And the reason I moved it over to pickup was because health potion and experience gem don't really do much by themselves. This doesn't mean that we're gonna use the pickup class for everything. So if you recall in Vampire Survivors, there are a lot of different kinds of pickups. Okay, there are pickups for, there's one pickup that causes you to spew fire, there's one pickup that causes you to stop time, and there's another one that causes you to attract all the gems to you, right? So for the more complex pickups, we will still subclass the pickup class over here because there's gonna be a lot more code. And for the effects of the pickup, because right now it's pretty rudimentary, okay, we can handle everything in the pickup class. So I'm just moving this over to pickup, and what we're gonna do is, remember that we want to make sure our pickups only apply the effects after they reach the player. Whenever the pickup is destroyed, we can assume that the pickup has reached the player. To that end, we are just gonna add a destroy, an onDestroy function to our pickup class, which is right here. So this onDestroy function, what it does is that it detects whenever the pickup is destroyed, and then it just applies its effects. So we've made it virtual because in the future, if we want to subclass the pickup class for, let's say, the more elaborate pickups, we can do so. And then it's protected so that it's only accessible by child classes of the pickup class. So here we are checking if the experience or the health is not equals to 0, and only if it's not equals to 0, we will call either restore health or increase experience. Okay, so it's possible also for pickup to reduce your experience or reduce your health. Okay, if you supply negative values. It's just that we don't want the effects to apply when the value is 0 itself. And the reason for that is because it's possible for us to add additional effects to increase experience and restore health later on. Let's say if you want to create an item that boosts the amount of health that you get from healing. Let's say for every time you get healed, you get 1 extra hit point. Okay, if we do that, and then if we have an experience gem, because it heals 0 health, it will still trigger any healing effects. So we don't want any healing effects to apply when the item is not supposed to heal, which is why we exclude calling restore health or increase experience when the values are 0. Target is here because as whatever pickup we have is flying towards us, it's possible for the player to die. So it's possible you pick up a health potion, before it reaches you, you die. Okay, in such cases, if you die, then target becomes null. If target becomes null, then target dot increase experience or target dot restore health is gonna become null. This will give you a missing reference exception or a null reference exception. Again, this is something that we have explored a lot. We have a video for that, and we will drop the link to that video when we turn this into a part 17 video. Okay, so now that we have merged the experience gem and the health potion into the pickup, okay, one last thing we have to merge into the pickup script, and that is the bobbing animation. Alright, so the idea behind putting the bobbing animation as a separate script is so that you can apply this animation script to other objects. The problem is that the bobbing animation script was coded to work with pickup. Even if it's separate class, it cannot work without a pickup component, so it becomes a little bit redundant, which is why we want to merge this into the pickup class. Another reason that this merging is good for our program is because generally if you have different behaviors spread out over different scripts, right, it becomes harder for Unity to retrieve the values because they can be stored in different parts of your memory, and then the further away they are, the harder it is to retrieve all their independent values. Okay, so when you have everything in the same class, then variables inside the class will always be stored in the same location, and it's gonna be easier for Unity to access them, which again means that your code will run faster. So very fortunately, the bobbing animation actually merges quite well into the pickup script. I am just gonna transfer all of these variables into pickup and make a few adjustments to how they are organized. Alright, so the three main variables we have here are frequency, magnitude, and direction. And magnitude can be combined in direction because vector can represent magnitude as well. So I'm gonna move these three variables into pickup, but it's gonna be a little bit different. And how it's different is that I'm going to put this as a struct. Okay, so only the frequency and direction needs to be transferred over just to save the data of the bobbing animation. Okay, you have frequency, you have direction. And this is saved under a struct. So a struct is essentially just a class, but they are passed by value. So this struct is now only going to exist inside the pickup script. A struct, that you can think of them as classes, right? They're just classes. Okay, later on I'll show you how this appears inside the inspector and it'll make sense to you. So whenever we declare a struct, we are able to create variables of that type that the struct is. Okay, so this variable is going to contain two values, frequency and direction. Okay, and then over here we are specifying a default value for the variable, and because this variable is a struct, it has two default values because there are two properties inside the struct here. So I'm declaring the default value for the frequency to be 0.2 and the default direction here will be 0 and 0.3. So with the bobbing animation struct set up and the variable set up, I can now add a else condition over here, and over here I can just transfer the formula over to our pickup script. And of course, when we transfer this, we are gonna have to also change the variable names a little bit because we changed the variable names in bobbing animation over here, right? Right now it's stored inside a struct, so we have to put bobbing animation dot direction and bobbing animation dot frequency. Magnitude we didn't transfer over, so we'll just delete this. And finally, we have this initial position here. What is initial position? This records where the object is initially, so that it's always gonna bob relative to where it's supposed to be, right? So the initial position is just where the pickup is supposed to be. So this will be a vector 2, and this will be a private vector 2 over here. And how the pickup is gonna work is that whenever it's spawned, it's gonna record where it's supposed to be. It's gonna stay there, but it's gonna move around. So the initial position is gonna be part of the formula for the pickup. So we are also going to add a protected virtual again so that we can override it in child classes. And inside the start function here, we are going to just set the initial position. So I would say the bobbing animation script actually fits very nicely into the pickup script because the pickup script does two things, right? If it's not collected, it will just bob. If it's collected, it will start moving towards the player. So the if and the else here is just perfect. And once we add all of this stuff, we will be able to update our prefabs so that they start working. So last thing we have to do is just delete the bobbing animation script. So now everything is contained inside pickup, right? Which means that when we go to our prefabs, we have to remove this is the old bobbing animation script, and then this is the old pickup script, the HealthPotion script, right? So we just replace that with new pickup script over here. And you'll see the pickup script here has a lifespan. Bobbing animation, because inside a struct, it becomes like that. And then there's frequency and then there's direction, and you see the whole thing is quite neat, right? It's quite clean, easy to read. And then you have bonuses here. We just have to modify it to the old value that we have. Okay, one last change, right, before we test this out is you have to reduce the pull speed to 10. Previously, if you recall, in the on trigger enter over here, what we have is we used add force. And add force, for those of you who are not familiar with physics, force is equals to mass times acceleration. So when you add a force to find out what is the change in the speed, this will be F over M. Alright, so what I'm trying to say to you is if you add force, the force is always going to be, the speed that you get is always going to be smaller than the force you apply because everything has mass, and then you're always dividing the force by a certain mass. Now we are not caring about how we're not using physics to move the object. We're just setting the position directly. So this means that if your pull speed is 300, it's going to be moving at 300 units per second. It's a totally different scenario over here. Okay, so because of that, we reduce the amount of pull speed 10 because right now it's just representing speed, not force. Oh, okay, so sorry, small mistake over here. Under player stats, right, this is supposed to be get component in children because the player collector is a child of the player stats, right? Okay, I'm gonna leave you to go and play around with this and test this yourself. Okay, I think it's pretty cool that the homing feature is working. So before I wrap up this stream, there are two more things I want to cover. Okay, one of it is bug fix, and the other one is just a quality of life improvement. Okay, so the first thing is the bug fix, which is under 4B of the article. So I'm going to take some damage on the player, scale this up, and now if I pick up the health potion, right, the health doesn't update. And only after I get damage does the health update, and this is because just small oversight on the PlayerStat script. Where is this oversight? When we have increased health, sorry, restore health over here, we also have to update health bar. Otherwise, the health bar will not update. And same thing under recover. So if you have Palmer Roller and the character is healing, the healing doesn't actually reflect on the health bar until you take damage. So right now only take damage updates the health bar, which is why you only see whenever you heal the character, you have to take damage, then the health bar updates. The other thing that I want to address isn't really a bug fix, but it's possible in Vampire Survivors, happens a lot, right? When you get big AoE weapons, that multiple enemies will die at the same time and you get a bunch of gems on the floor. When that happens, because we have a bobbing animation, the items will all bob in the same rhythm. It's not a big problem, just looks very robotic. So one way we can fix this is we can head over to the pickup script and we can just randomize the bobbing animation a little bit. Okay, so we'll introduce a float initial offset. And what this does is this is just going to be a random value between the frequency and so between 0 and the frequency. Essentially what this is this is just a random value that we add to the time in the formula over here. Okay, so what we want to do is we don't want the object to always start at 0. We want some of the objects to start curving here, some to start curving just anywhere random between the peak of the curve and the bottom. Okay, so then by adding this random offset over here, this will ensure that our curve doesn't always start in the same place, and this will give us some amount of randomness to the animations of the objects, which makes everything more organic. That's about it. In the next part, what I'll do is what I initially set out to do, which is to generate or rather create the rest of the stat. So we have 7 more stats. Thanks for your support. Thanks for all the kind comments. It's really great. I always appreciate comments because it helps to remind us of why we are doing all of this stuff, right? It's for you guys. Okay, so thanks for tuning in for those of you who did. That's all for today.